All right, today we're going to talk about average atomic mass. Now, average atomic mass is the average mass that an element has, and you're taking two things into account. The mass of each isotope. Remember, an isotope is going to be the same element, different numbers of neutrons. Okay, and then how often each isotope occurs. So not every single isotope of an element occurs at the same percentage. So an example of that would be carbon. So if we look on the periodic table, the box for carbon will look like 6C12.01. This bottom number is the average atomic mass. Well, normal carbon, or I guess the most common carbon, has a mass number of 12, which means that we have 6 protons and 6 neutrons. But if we look at this average atomic mass number, it's 12.01. It's not exact. And we know that you can't have a half of a neutron, you can't have a half of a proton, so how is that mass number different? It's because we have many isotopes of carbon, and so when we average them all together, you get a number that's a little bit larger than 12. The more often that a particular type of isotope occurs, the more times it factors into this average, so that number is closest to it. We're going to talk a little bit more about that in a minute. These numbers do have units. The unit is not on your periodic table. But the units for average atomic mass are AMU, and that stands for atomic mass unit. So when we are figuring out the average atomic mass, the unit that you're going to put at the end of your number is AMU. Just in case you were wondering where you can find this on your reference packet, it is in your periodic table. So here, again, I use the example for carbon, 6C, carbon 12.01. The bottom number is your average atomic mass. The top number is your atomic number, which is going to be your protons. Okay, so the formula we're going to use is this one. So go ahead and write this down, and I'm going to explain it. So the formula is broken up into each of the individual isotopes. So each set of parentheses is for however many isotopes we have. Right now, I have 2 isotopes set up, but it can be however many naturally occurring isotopes that particular element has. So what we're going to do is we're going to take the mass of the isotope and how often it occurs, okay? And you multiply those together. And then you're going to add it to the mass of your second isotope multiplied by its percent, how often it occurs. And you do that for however many isotopes you have. Then when you're all done, you can divide it by 100. Now, you can do this slightly different. Instead of keeping your percent in a percent, you can convert to the decimal form. And all that means is that you are dividing the percent by 100 and then not at the end. Okay, so you're either going to divide the percent by 100 for each of the isotopes, or you keep the percentage as a percentage and you divide once by 100 at the end. Either one of those options work just fine. So let's go ahead and do some practice problems to make sure we can do this. And I will keep, oh, you have this written down, it's okay. All right, so copper has 2 naturally occurring isotopes, one with a mass of 62.93 AMU and the other with a mass of 64.93 AMU. Isotope 1 occurs 69.2% of the time, and isotope 2 occurs 30.8% of the time. What is the average atomic mass of copper? Okay, so we have 2 masses and we have 2 percents. So remember, that we have 62.93 AMU. So that is the mass of isotope 1, and we're going to multiply it by its occurrence. So that is 69.2%. And then we are going to add it to 64.93 AMU times its natural occurrence, which is 30.8%. Now, because I kept these in percents, I'm going to divide by 100 at the end. So what I would do is I would do everything in the parentheses first, then add them together, and then divide by 100. So 62.93 times 69.2 plus parentheses 64.93 times 30.8. And then I divide by 100, and I get 63.55. Okay, and then the units for average atomic mass are AMU. So that's your final answer. Now, if you look on the periodic table, it should be pretty close. So we can find copper on the periodic table, and it is 63.55, and that's exactly what we got. All right, let's do the next one. Here it says calculate the average atomic mass of bromine. The two isotopes of bromine have atomic masses and relative abundances of 78.92 AMU, and that's at a 50.69%, and 80.92 AMU, which is at 49.31%. So this time I'm going to divide my percents by 100 in the beginning. I'm just showing you both options here. Okay, so I have 78.92 AMU times 0.5069, because I'm dividing it by 100, plus 80.92 AMU times 0.4931, again, because I divided it by 100. So now I don't need to divide by 100 at the end. So now I plug this into my calculator. So 78.92 times 0.5069 and parentheses plus 80.92 times 0.4931, and I get 79.91. And again, I want my units, which is AMU. You can double check yourself. So bromine has 79.90. That's 79.91. It's really close.